Picture this. You're standing by the banks of the ancient Nile River, watching as a massive crocodile emerges from the murky waters with your child clenched between its jaws. The beast speaks, yes, speaks, and makes you an offer that will haunt philosophers for over 2,000 years. I will return your child, the crocodile says, but only if you can correctly predict what I'm going to do. Guess right, and your child lives. Guess wrong. The crocodile's eyes glitter with ancient malevolence. What sounds like a simple riddle is actually one of the most mind-bending logical paradoxes ever conceived, a puzzle that reveals the terrifying boundaries of human reasoning and shows us how language itself can become a trap that even the most brilliant minds cannot escape. Welcome to the crocodile paradox, where logic doesn't just fail, it devours itself. I'm about to take you on a journey through one of philosophy's most elegant and devastating thought experiments. The crocodile paradox isn't just an ancient brain teaser. It's a window into the fundamental limitations of logical thinking, a demonstration of how our most sophisticated reasoning tools can turn against us when pushed to their limits. This paradox has been tormenting brilliant minds since ancient Greece, inspiring heated debates among philosophers, logicians, and mathematicians for over 2 millennia. Today, we're going to dissect this intellectual monster piece by piece, explore its origins in the dusty scrolls of antiquity, and discover why this seemingly simple story about a talking crocodile continues to challenge our understanding of truth, logic, and reality itself. But here's what makes this journey truly fascinating. By the end of this exploration, you'll understand not just the crocodile paradox, but an entire family of logical contradictions that reveal the strange, sometimes terrifying landscape where mathematics meets philosophy. You'll see how this ancient riddle connects to modern artificial intelligence, quantum mechanics, and the very foundations of human knowledge. So buckle up, because we're about to dive deep into intellectual waters where even the most careful reasoning can leave you drowning in contradiction. Let's begin with the full, devastating beauty of the crocodile paradox. Here's how the ancient story unfolds. A crocodile has stolen a parent's child. The reptilian kidnapper, possessing unusual intelligence and a twisted sense of fair play, approaches the distraught parent with a proposition. I will give you one chance to save your child, the crocodile declares. Simply predict what I will do. If your prediction is correct, I will return your child unharmed. If your prediction is wrong, I will keep the child forever. The parent, desperate and thinking quickly, responds, You will not return my child. And here's where logic begins to eat its own tail. If the parent is correct, if the crocodile indeed will not return the child, then, according to the agreement, the crocodile must return the child because the prediction was accurate. But if the crocodile returns the child, then the parent's prediction was wrong, which means the crocodile should not return the child. If the parent is incorrect, if the crocodile was actually planning to return the child, then the crocodile should keep the child because the prediction was wrong. But by keeping the child, the crocodile makes the parent's prediction correct, which means the child should be returned. Welcome to logical hell, where every path leads to contradiction. This isn't just a clever word game. What we're witnessing is a fundamental breakdown in the logical system we use to navigate reality. The crocodile paradox demonstrates that under certain conditions, our most basic tools of reasoning, if-then statements, predictions, and logical consistency can become self-defeating. The beauty and horror of this paradox lies in its simplicity. Unlike complex mathematical proofs or elaborate philosophical arguments, the crocodile paradox uses everyday concepts, promises, predictions, and consequences. Yet it creates a logical black hole from which no consistent reasoning can escape. The crocodile paradox didn't emerge from a vacuum. It belongs to a rich tradition of logical paradoxes that ancient philosophers use to probe the boundaries of human reasoning. The earliest recorded versions appear in the works of ancient Greek and Roman scholars, though the exact origins remain shrouded in scholarly debate. Some historians trace the paradox back to the Stoic philosophers of ancient Greece, who were obsessed with logic and the precise use of language. The Stoics believed that clear thinking could solve virtually any problem. But paradoxes like this one revealed uncomfortable limitations in their logical systems. Others point to the influence of ancient legal traditions, where precise wording and conditional statements could mean the difference between justice and injustice. In this context, the crocodile paradox might have originated as a cautionary tale about the dangers of poorly constructed contracts and agreements. What's particularly fascinating is how the paradox reflects ancient attitudes toward both nature and language. Crocodiles, in many ancient cultures, represented chaos and primordial danger, forces of nature that existed outside human moral systems. By making the crocodile capable of speech and logical reasoning, the paradox creates a collision between the civilized world of human logic and the unpredictable realm of natural forces. The choice of a child as the victim isn't accidental either. Children represent innocence, future potential, and our deepest emotional attachments. By placing a child's fate at the center of this logical trap, the paradox forces us to confront the possibility that pure reasoning, divorced from human emotion and moral intuition, might be fundamentally inadequate for navigating the most important decisions in life. Ancient scholars recognized that this wasn't just an intellectual puzzle. It was a mirror reflecting the limitations of human knowledge itself. They understood that some logical structures, when pushed to their limits, reveal contradictions that cannot be resolved through more logic. Instead, they demand that we question the foundations of reasoning itself. To truly understand the crocodile paradox, we need to dissect its logical structure with surgical precision. At its heart, this paradox belongs to a family of logical problems, known as self-referential paradoxes, statements that somehow refer to themselves in ways that create inescapable contradictions. The key mechanism here is what logicians call a self-fulfilling prophecy loop. Combined with a self-defeating prophecy loop, the parent's prediction doesn't just describe what might happen, it actually influences what will happen, creating a feedback loop that makes consistent logic impossible. Let's break this down step by step. First, we have a conditional agreement. If you predict correctly, you get the child back. If you predict incorrectly, you don't. This seems straightforward enough. It's the kind of if-then statement that forms the backbone of logical reasoning. Second, we have a prediction that refers to its own consequences. You will not return my child. This prediction isn't about some external event that the predictor cannot influence. Instead, it's about an action that depends directly on whether the prediction itself is true or false. Third, we have the logical evaluation. The truth or falsehood of the prediction depends on whether the prediction turns out to be true or false. This creates what mathematicians call a strange loop, a hierarchical system that somehow circles back on itself. The result is a logical structure that cannot find a stable state. Every potential resolution immediately generates its own contradiction. It's like trying to build a foundation that supports itself. No matter how you arrange the logical components, the structure collapses under its own weight. What makes this particularly mind-bending is that each individual component of the paradox seems perfectly reasonable. Conditional agreements are commonplace. Predictions about future events are normal. The logical evaluation of whether predictions come true is standard practice. But when these ordinary elements combine in just the right way, they create something extraordinary, a logical impossibility. This reveals something profound about the nature of logic itself. We often think of logical reasoning as a universal tool, something that can, in principle, resolve any well-defined problem. The crocodile paradox suggests that this confidence might be misplaced. There are logical structures so twisted that they defeat logic itself. The crocodile paradox isn't alone in the universe of self-referential, logical nightmares. It belongs to a broader family of paradoxes that reveal similar cracks in the foundation of human reasoning. Understanding these related puzzles helps us see the full scope of the logical problems we're dealing with. Consider the famous liar paradox, first formulated by the ancient Greek philosopher Epaminondas. This statement is false. If the statement is true, then it must be false. If it's false, then it must be true. Like the crocodile paradox, this creates an endless loop of contradiction. Then there's the barber paradox, conceived by philosopher Bertrand Russell. In a town, there's a barber who shaves only those people who do not shave themselves, who shaves the barber. If he shaves himself, then he belongs to the group of people who shave themselves, which means he shouldn't shave himself. If he doesn't shave himself, then he belongs to the group of people the barber shaves, which means he should shave himself. What's fascinating is how these paradoxes follow a similar logical architecture. They all involve self-reference, situations where a statement, rule, or condition somehow applies to itself. They all create binary situations where both possible outcomes lead to contradictions. And they all reveal that our ordinary logical tools become powerless when faced with certain types of self-referential structures. The crocodile paradox adds a unique element to this family: the emotional stakes and the temporal dimension. Unlike the abstract liar paradox or the hypothetical barber paradox, the crocodile paradox unfolds as a story with real consequences. The parent must make a prediction in real time, under emotional duress, about an outcome that depends on the prediction itself. This temporal element introduces another layer of complexity. The parent cannot simply refuse to engage with the paradox. A child's life hangs in the balance. The prediction must be made, even though making any prediction creates logical impossibility. This forces us to confront not just the theoretical limitations of logic, but the practical problems that arise when logical paradoxes intrude into situations requiring immediate action. Modern variations of the paradox have explored different scenarios: computer programs that predict their own behavior, legal contracts that reference their own validity, and artificial intelligence systems that model their own decision-making processes. Each variation reveals new facets of the same fundamental problem: the dangerous intersection of self-reference and logical reasoning. The crocodile paradox isn't just a clever logical puzzle. It's a window into some of the deepest questions in philosophy. What does it mean for a statement to be true? Can logic solve every well-defined problem? Are there fundamental limits to human reasoning? The paradox forces us to grapple with these questions in ways that pure, abstract philosophy cannot. One of the most profound implications concerns the nature of truth itself. We normally think of truth as a simple, binary property. Statements are either true or false. The crocodile paradox suggests that this binary framework might be inadequate for certain types of statements. When the parent says, "You will not return my child," this prediction seems to exist in a strange, logical space that transcends ordinary truth values. Some philosophers have responded to this challenge by proposing alternative logical systems. Three-valued logic, for example, introduces a third truth value, undefined, or neither true nor false. For statements that cannot be consistently evaluated as true or false. In this framework, the parent's prediction would be classified as undefined, potentially resolving the paradox by refusing to play by its rules. But this solution comes with its own philosophical costs. If we allow statements to be undefined, we must ask, what does it mean for something to be undefined? How do we make practical decisions based on undefined statements? In the context of the crocodile paradox, classifying the parent's prediction as undefined doesn't help the parent or the child. Someone still needs to decide whether the child gets returned. The paradox also raises profound questions about the relationship between language and reality. Our ability to construct the paradox depends on language that can refer to itself, words and sentences that somehow point back to their own meaning or truth value. This suggests that natural language, despite its power and flexibility, might contain structural features that make certain types of logical reasoning impossible. Furthermore, the paradox illuminates the problem of infinite regress in logical analysis. When we try to evaluate the parent's prediction, we find ourselves in an endless loop. The truth of the prediction depends on its own truth value, which depends on its own truth value ad infinitum. This suggests that some logical problems cannot be solved by deeper analysis. More thinking just leads to more contradiction. Perhaps most unsettling, the crocodile paradox hints that human reasoning itself might be fundamentally limited. We've built entire civilizations on the assumption that logical thinking can, in principle, solve any well-defined problem. The existence of paradoxes like this one suggests that this assumption might be false, okay? That there are problems that defeat logic, not because they're poorly defined, but because they reveal internal contradictions in logical reasoning itself. The ancient crocodile paradox has found unexpected relevance in the digital age, particularly in computer science and artificial intelligence. As we build increasingly sophisticated machines capable of reasoning about their own behavior, we encounter modern versions of the same logical traps that puzzled ancient philosophers. Consider the halting problem, one of the most famous results in theoretical computer science. Computer scientist Alan Turing proved that it's impossible to write a program that can determine, for any given program and input, whether that program will eventually halt or run forever. The proof relies on a self-referential construction remarkably similar to the crocodile paradox. We imagine a program that analyzes its own behavior and creates a contradiction. In artificial intelligence, self-referential paradoxes create practical challenges for systems that need to model their own decision-making processes. An AI system trying to predict its own future actions faces a version of the crocodile paradox. Its prediction about its own behavior can influence that behavior, potentially invalidating the prediction. Machine learning systems encounter similar problems when they try to learn about their own learning processes. A neural network that attempts to model its own training dynamics must somehow account for the fact that its model of itself will change as it learns more about itself. This creates feedback loops that can destabilize the learning process in ways that echo the logical instability of the crocodile paradox. Database systems face their own versions of self-referential challenges. Consider a database that stores information about its own structure and operations. Queries about the database's own query processing capabilities can create paradoxical situations, where the answer to a query depends on the query's own execution. Even in cybersecurity, we find echoes of the ancient paradox. Security systems that try to monitor their own security status face logical challenges. If a security breach could compromise the monitoring system itself, how can the system reliably report on its own integrity? These modern applications reveal that the crocodile paradox wasn't just an abstract philosophical curiosity. It identified a fundamental feature of self-referential systems that becomes increasingly important as we build more sophisticated technologies. The paradox serves as a warning about the limits of self-modeling and self-prediction in complex systems. Software engineers have developed various strategies for managing these challenges, from careful system design that avoids problematic self-reference to formal verification techniques that can identify potential paradoxes before they cause system failures. But the fundamental problem remains. Any sufficiently complex system that can reason about itself will eventually encounter versions of the logical traps first identified by ancient philosophers. The crocodile paradox's exploration of self-reference and logical contradiction finds surprising resonance in modern physics, particularly in quantum mechanics and the measurement problem. These connections reveal that the logical puzzles identified by ancient philosophers might reflect deep features of physical reality itself. Consider the famous quantum measurement paradox. Before measurement, a quantum system exists in a superposition of multiple states. The act of measurement somehow collapses this superposition into a single, definite state. But here's the puzzle. If the measuring device is also a quantum system, what causes its state to collapse? And if we need another measuring device to measure the first measuring device, we face an infinite regress, reminiscent of the logical loops in the crocodile paradox. The observer effect in quantum mechanics creates its own version of self-referential challenges. The presence of an observer changes the behavior of the observed system. But if the observer is also a physical system subject to quantum laws, who or what observes the observer? This creates a hierarchy of observation that, like the crocodile paradox, seems to spiral into infinite regress. Schrodinger's famous cat thought experiment explicitly explores these self-referential puzzles. The cat's fate depends on a quantum measurement, but the cat itself is a macroscopic system that should, in principle, be describable by quantum mechanics. The paradox arises from trying to apply quantum logic to a system that includes the observation of its own quantum state. In cosmology, similar paradoxes emerge when we try to understand the universe's ability to observe itself through conscious observers like humans. If consciousness emerges from the universe's own physical processes, how can the universe use consciousness to understand its own fundamental nature? This creates a self-referential loop that echoes the structure of the crocodile paradox. The many worlds interpretation of quantum mechanics attempts to resolve measurement paradoxes by proposing that all possible measurement outcomes occur in parallel universes. In this framework, the parent in the crocodile paradox might exist in multiple parallel worlds. In some worlds, the child is returned, in others, not. But this solution raises its own questions about self-reference. In which world does the parent's prediction count as correct? String theory and theories of quantum gravity face similar challenges. When they attempt to describe the emergence of space-time itself from more fundamental quantum processes. How can a theory describe the emergence of the very space-time framework in which the theory's equations are supposed to operate? This meta-theoretical puzzle reflects the same kind of self-referential challenge that makes the crocodile paradox so confounding. These connections suggest that the logical problems identified by ancient paradoxes might not be mere curiosities of language and logic, but reflections of fundamental features of reality itself. The universe's apparent ability to contain observers capable of understanding the universe creates the same kind of self-referential structure that generates logical paradoxes. Over the centuries, brilliant minds have proposed numerous solutions to the crocodile paradox, each offering insights into the nature of logical reasoning, while ultimately revealing new dimensions of the puzzle's resistance to resolution. Examining these attempted solutions helps us understand both the paradox's enduring power and the limits of human logical ingenuity. The most straightforward approach attempts to break the paradox by rejecting its initial setup. Some argue that the crocodile's promise is inherently meaningless. That promise is contingent on correct predictions about the promise's own fulfillment are logically incoherent and therefore invalid. This approach treats the paradox as a category error, like asking, "What is the color of a Wednesday?" While this dismissal has some logical merit, it sidesteps rather than solves the core problem. The paradox demonstrates that certain types of conditional statements can generate contradictions, regardless of whether we call them meaningful or meaningless. The logical structure that creates the contradiction exists independently of our willingness to take the scenario seriously. Another resolution strategy involves temporal analysis, carefully examining the timing of prediction, evaluation, and action. Some logicians argue that the parent's prediction refers to a future state that doesn't yet exist when the prediction is made, creating a temporal gap that breaks the self-referential loop. Make its decision after hearing the prediction, but before the prediction's truth value is established. This temporal approach faces its own challenges. Even if we introduce time delays, the fundamental logical dependency remains. The crocodile's ultimate decision must somehow account for the prediction's accuracy, creating the same circular dependency that generated the original paradox. Time might delay the contradiction, but it doesn't eliminate it. Game theory offers another perspective, treating the paradox as a strategic interaction between rational agents. In this framework, the parent and crocodile are players in a game where the payoffs depend on prediction accuracy. Game theoretic analysis can identify stable strategies and equilibrium solutions. But these mathematical solutions don't resolve the underlying logical contradiction. They simply provide practical decision-making frameworks that work around the paradox. Formal logic has developed sophisticated tools for handling self-referential statements, including hierarchical truth theories and paraconsistent logics that can tolerate contradictions without logical explosion. These approaches can contain the paradox within carefully controlled logical frameworks, but they require abandoning some fundamental principles of classical logic. Perhaps the most honest approach acknowledges that some logical structures cannot be resolved within the framework of classical reasoning. This metalogical perspective treats the crocodile paradox not as a problem to be solved, but as a diagnostic tool that reveals the boundaries of logical thinking. Just as mathematical theorems like Gödel's incompleteness results show that mathematical systems cannot prove their own consistency, the crocodile paradox demonstrates that logical systems cannot handle all forms of self-reference. The failure of resolution attempts is itself philosophically significant. It suggests that human reasoning, despite its remarkable power and flexibility, encounters fundamental limits when confronted with certain types of self-referential structures. These limits aren't failures of human intelligence. They're features of logic itself. The crocodile paradox has transcended academic philosophy to become a cultural touchstone for discussions about logic, reasoning, and the limits of human understanding. Its influence extends far beyond university classrooms, appearing in literature, popular science, and even everyday conversation about impossible choices and logical contradictions. In literature, writers have used variations of the paradox to explore themes of fate, free will, and the adequacy of rational thinking. The structure of impossible choices that defeat logic appears in stories ranging from ancient mythology to modern science fiction. Characters face dilemmas where every logical response leads to contradiction, forcing them to confront the limits of rational decision-making. The paradox has become a favorite tool for educators, introducing students to philosophical thinking. Its combination of narrative accessibility and logical sophistication makes it an ideal gateway for exploring deeper questions about truth, reasoning, and the foundations of knowledge. Students who might find abstract logical notation intimidating can easily grasp the story of a parent facing an impossible choice. Popular science writing frequently uses the crocodile paradox as an example of how seemingly simple questions can reveal profound complexities. The paradox serves as a bridge between ancient wisdom and modern scientific understanding, showing how logical problems identified thousands of years ago continue to challenge contemporary thinkers. In professional contexts, the paradox has become shorthand for situations where standard decision-making procedures break down due to self-referential complications. Business strategists, legal theorists, and policy analysts reference the paradox when discussing scenarios where conventional analysis fails due to circular dependencies and feedback loops. The paradox has also influenced popular understanding of artificial intelligence and machine reasoning. As AI systems become more sophisticated, the public increasingly recognizes that machine intelligence might face the same kinds of logical limitations that puzzle human thinkers. The crocodile paradox provides an accessible way to discuss the possibility that artificial intelligence might encounter fundamental barriers to self-understanding and self-prediction. Social media and internet culture have embraced the paradox as a meme-worthy example of mind-bending logical puzzles. Online discussions often reference the paradox when describing situations where logical analysis seems to spiral into contradiction or absurdity. This popularization has introduced new generations to philosophical thinking through digital platforms and informal discussion. The enduring cultural appeal of the crocodile paradox reflects its unique combination of intellectual depth and emotional resonance. Unlike abstract logical puzzles, the paradox tells a story with genuine emotional stakes. The image of a parent desperately trying to save a child through logical reasoning creates an immediate human connection that makes the philosophical implications more compelling and memorable. As we stand on the threshold of increasingly sophisticated artificial intelligence, the crocodile paradox offers crucial insights into the fundamental challenges facing machine reasoning and self-aware systems. The logical traps identified by ancient philosophers might represent permanent barriers to certain types of artificial intelligence capabilities. Consider the challenge of building AI systems capable of accurate self-modeling. Such systems would need to predict their own future behavior, analyze their own decision-making processes, and evaluate their own performance. The crocodile paradox suggests that this kind of self-referential reasoning might be inherently unstable, creating feedback loops that prevent accurate self-understanding. Machine learning systems already encounter versions of this challenge. When an AI system tries to learn about its own learning process, it faces a version of the paradox. The system's model of its own learning changes as it learns more about itself. This can create instabilities that prevent the system from reaching stable self-understanding. The paradox also has implications for AI safety and alignment research. If we want to build AI systems that can be trusted to pursue human values, we might need those systems to be capable of reasoning about their own goals and behaviors. But the crocodile paradox suggests that sufficiently sophisticated self-referential reasoning might be impossible, potentially limiting our ability to create fully self-aware and self-correcting AI systems. Autonomous systems face practical versions of these challenges when they need to make decisions about their own operation. An autonomous vehicle trying to predict its own response to unexpected situations faces a logical structure similar to the crocodile paradox. Its prediction about its own behavior could influence that behavior in ways that invalidate the prediction. The development of artificial general intelligence might be fundamentally constrained by self-referential paradoxes. If AI systems need to be capable of reasoning about their own reasoning processes, they might encounter the same logical barriers that make the crocodile paradox unsolvable. This could represent a fundamental limit on the kinds of intelligence that can be implemented in computational systems. However, the paradox also suggests potential strategies for managing these challenges. Just as humans can recognize and work around logical paradoxes without being paralyzed by them, AI systems might develop robust procedures for handling self-referential contradictions. The key might be building systems that can tolerate logical inconsistency in limited domains while maintaining overall functionality. Understanding these limitations is crucial for setting realistic expectations about AI capabilities. The crocodile paradox reminds us that even perfect logical reasoning might be insufficient for solving all well-defined problems. This suggests that human-AI collaboration might be essential not just for practical reasons, but because human intuition and creativity might be needed to navigate around logical barriers that defeat pure reasoning. The journey through the crocodile paradox reveals something profound about the human condition. Our remarkable ability to create logical structures that surpass our ability to fully comprehend them. This ancient puzzle serves as a humbling reminder that intelligence, no matter how sophisticated, encounters fundamental boundaries. What makes this paradox particularly fascinating is how it demonstrates the double-edged nature of human reasoning. Our capacity for abstract thought, language, and logical analysis enables us to construct scenarios that reveal the limits of these very same capabilities. We can describe logical impossibilities even when we cannot resolve them. The paradox also illuminates the relationship between emotion and logic in human decision-making. The parent in the story faces a situation where pure logical analysis fails, yet a decision must still be made. Real life constantly presents us with situations where perfect logical analysis is impossible, impractical, or insufficient. The crocodile paradox suggests that wisdom might lie not in pursuing perfect logical consistency, but in developing judgment that can function despite logical limitations. For individuals navigating complex decisions, the paradox offers a valuable lesson. Some problems cannot be solved through more analysis. Sometimes the most sophisticated thinking leads not to clear answers, but to deeper appreciation of complexity and uncertainty. Recognizing when we've reached the limits of logical analysis can be as valuable as the analysis itself. The paradox also speaks to the importance of intellectual humility. In an age where we're surrounded by sophisticated technology and complex information systems, it's tempting to believe that sufficiently advanced analysis can solve any problem. The crocodile paradox reminds us that even our most powerful intellectual tools have boundaries. Perhaps most importantly, the paradox illustrates the beauty of intellectual exploration that doesn't necessarily lead to resolution. The journey through the logical labyrinth of the crocodile paradox is valuable not because it provides answers, but because it reveals the fascinating architecture of human thought and the mysterious nature of logical reasoning itself. As we reach the end of our exploration, the crocodile paradox stands before us, not as a conquered puzzle, but as a gateway to deeper understanding of the magnificent and terrifying capabilities of human reasoning. This ancient thought experiment has revealed something extraordinary: our ability to construct logical structures that transcend our ability to fully resolve them. We've seen how a simple story about a parent, a child, and a talking crocodile opens into vast territories of philosophical inquiry, touching everything from the foundations of mathematics to the frontiers of artificial intelligence. The paradox connects ancient wisdom to quantum mechanics, classical logic to modern computer science, abstract philosophy to practical decision-making. What emerges from this journey is not defeat, but wonder. The crocodile paradox doesn't represent a failure of human intelligence. It represents intelligence sophisticated enough to discover its own boundaries. Kaha. Like a mathematical theorem that reveals the limits of mathematical systems. The paradox shows us the edges of logical reasoning itself. The parent facing the crocodile's impossible choice represents all of us confronting the fundamental uncertainties and logical limitations that define the human condition. We live in a world where perfect logical analysis is often impossible. Yet decisions must still be made, actions must still be taken, and life must still be lived. Perhaps the real lesson of the crocodile paradox is that wisdom lies not in conquering every logical challenge, but in developing the judgment to navigate uncertainty with grace. In recognizing the limits of our reasoning, we might paradoxically discover a deeper kind of understanding, one that embraces mystery without abandoning the pursuit of knowledge. The ancient crocodile, with its impossible bargain, continues to speak across the millennia. Its message is both humbling and liberating. We are creatures capable of constructing logical infinities we cannot fully comprehend. And in that very capacity lies both the limitation and the grandeur of human consciousness. The paradox endures because it captures something essential about the relationship between mind and reality, between the logical structures we create and the world we inhabit. In the end, the crocodile paradox doesn't just challenge our reasoning, it celebrates the magnificent complexity of minds capable of reasoning about reasoning itself, even when that reasoning leads us into the heart of logical impossibility. And perhaps that's the most human thing of all, our willingness to follow logic wherever it leads us into the jaws of paradox itself.